All right, so let's look at the exercises from section 4.2. So for this first question here, we are told to find a particular solution for this equation. So we're looking at non-homogeneous second order equations now. But to find solutions for these, we first have to look at the, homogeneous counterpart for these equations. So I'm going to write that x double prime minus 6x prime plus 25x equals 0. And the corresponding characteristic equation that comes from that, r squared minus 6r plus 25 equals 0. Don't believe this factors or is even going to be real roots. So r equals negative b, so 6 plus or minus the square root of 36 minus 4 times 1 times 25, 100, all over 2a, so 2. So 6 plus or minus the square root of negative 64, so 8i over 2. So 3 plus or minus 4i. All right, so what does that mean for my roots? So e to the 3 plus 4i t, that's equal to e to the 3t times cosine 4t plus I sine 4t. Okay, so my general solution looks like this, or my complementary solution. C1 e to the 3t cosine 4t plus C2 e to the 3t sine 4t. So the way we find the particular solution is by looking at the forcing function. So in this case, that's 64 e to the negative 2. So I'm going to make an educated guess. The particular solution, I'm going to assume that it has the same form. So also exponential and with the same decay rate. So e to the negative t, but I don't know what the, what constant, what its coefficient is going to be. So from that particular solution, what is its first derivative? Negative a e to the negative t. Second derivative is going to be simply a e to the negative t. And I'm going to plug these values back into the differential equation. So the second derivative, a e to the negative t, minus 6 times negative a, so plus 6a e to the negative t, plus 25 a e to the negative t. The sum of these three things. So just a reminder, these three terms come directly from the differential equation I'm trying to solve. And I know the sum of these three things equals 64 e to the negative t. So I'm going to go ahead and factor out the e to the negative t. And what remains is a plus 6a plus 25a equals 64 e to the negative t. The coefficients of e to the t have to be identical on either side. So what do I have on the left here? I have 25a plus 6a plus a. I have 32a equals 64, which means that a equals 2, which allows me to, lock in what exactly my particular solution is. So now I can write down, or at least as far as I can, what my solution to this equation is. C1 e to the 3t cosine 4t plus c2 e to the 3t sine 4t plus 2e to the negative t. So that is the full solution, including the particular solution to this equation. Moving on. I think I accidentally did 11 as well. So yeah, find the general equation, the general solution for this one as well. This is the same equation, right? Yeah, it definitely is. All right, so did 11 at the same time. All right, so let's solve an initial value problem. So again, we can start with everything we learned about how to solve a homogeneous equation. We can start there. So we have r squared minus r minus 2 equals 0. Does this factor? I believe it should. So r minus 2r plus 1. R squared minus 2r plus r. Yeah, okay. So I should get r equals negative 1 and positive 2. So that means my complementary solution, yc of x, is equal to c1 e to the negative x plus c2 e to the 2x. So that's the complementary solution. What is my particular solution going to look like? Again, so it's going to mimic the form of your forcing function. My forcing function is x squared. So does that mean that my particular solution should look like ax squared? Well, partly. We got to generalize a little bit further, because what is 4x squared? Well, it's a polynomial. What kind of polynomial is it? It's a quadratic. Not all quadratics are just, simply a square, an x squared term. So I have to start from the most general kind of quadratic I can. So even though they might not all be represented, I'm going to have a linear term and a constant term as well. So this is going to be my particular solution. And from here, let's figure out what my derivatives are. First derivative will be 2ax plus b. C vanishes. And then yp double prime of x. That'll simply be 2a. All right. So if I take these three values to my differential equation, what do I get? I get 2a, because that's the second derivative, minus y prime, which is 2ax plus b, minus 2 times y, which is ax squared, plus bx, plus c, and that equals 4x squared. So how do I solve for these constants a, b, and c? So here's what I have. I have actually, it might be as simple as this. So let's be sure. I think the only term I have that's going to be x squared is going to be negative 2ax squared. Negative 2ax squared that comes from, this multiplication right here. So I have a suspicion that since negative 2ax squared equals 4x squared, that a will be negative 2. But let's be a little more rigorous and verify that. So to do that, I'm going to expand all this stuff out. 2a minus 2ax minus b minus 2ax squared minus 2bx minus 2c equals 4x squared. So now I'm going to group these things up by what power of x they have with them. So the x squared term has a negative 2a. What are all my x terms? I have a negative 2a. I have a negative 2b. Is that it for x's? Okay, and what else? What are my constants? Okay, anything that's free of a variable or free of x is 2a minus b minus 2c. So all the coefficients of x squared, x, and constant should equal the coefficients of those corresponding things on the right, which means I should be able to get a for free. So negative 2a should equal 4. That means that a should be negative 2. What else does that allow me to do? So what's my coefficient of x? It's negative 2a minus 2b. What's my coefficient of x on the right-hand side? Well, there is no x term, so we can say it's 0. So we know that a is negative 2. So that means 4 minus 2b equals 0. So b equals 2. All right, if b equals 2, so we got two pieces of information, a equals 2, or negative 2, b equals 2. All right, now we can use that final piece of information with the constants to figure out what c is. So I know that 2 times a minus b minus 2 times c equals whatever our constants equal on the right-hand side, which is a 0. So what do we get for c? So negative 4 minus 2 minus 2c equals 0, minus 6. So negative 2c equals 6. C equals negative 3. All right. So all told, we have this. Particular solution is negative 2x squared plus 2x minus 3. So again, we had to account for the fact that we might now have a quadratic that is without an x term and a constant term, and we definitely got all three terms represented. All right, so we're not quite done. So how do we get there? So here's what our solution looks like so far. Y of x equals c1 e to the negative x plus c2 e to the 2x minus 2x squared plus 2x minus 3. We have the means to figure out what these constants are. So to do that, let's plug in 0 for y or 0 for x. And I get c1 plus c2 minus 2 times 0 plus 2 times 0 minus 3 equals negative 1, which means that c1 plus c2 equals 2. All right, let's get a derivative now. Y prime of x equals negative c1 e to the negative x plus 2c2 e to the 2x minus 4x plus 2. Then y prime of 0 equals negative c1 plus 2c2 minus 4 times 0 plus 2 equals 1. So minus c1 plus 2c2 equals negative 1. So now I have a system of equations. c1 plus c2 equals 2. Negative c1 plus 2c2 equals negative 1. And conveniently, I can add straight down and my c1s will eliminate. So that gives me 3c2 equals 1, which means that c2 equals a third. And from there, if I plug in 1/3 for c2, that means c1 will equal whatever 2 minus a third is. c1 equals 2 minus 1/3, which will be 6/3 minus 1/3, so 5/3. All right. And I think we're done. All that is left to do is to, I'm going to do the lazy way and just swap out my C1 and C2, also because I'm running out of room. So 5/3 e to the negative x plus 1/3 e to the 2x minus 2x squared plus 2x minus 3. That is my fully fleshed out particular solution for this initial value problem. All right. Last one, same kind of process here. First things first, let's do characteristic equation. So r squared plus 2r plus 1 equals 0. That factors into something with a duplicated root. So r plus 1 squared equals 0. So I get r equals -1. So what is that complementary solution going to look like? So one of them is going to be c1 e to the negative t. But because I have a repeated root and I want my two constituent parts of my complementary solution not to be multiples of each other, I'm going to multiply by a power of t. So c2t e to the negative t. So that's my complementary solution. So what form do I want the particular solution to take? Well, that also has the form of a constant times e to the negative t. So I cannot let my particular solution interact with my complementary solution. So I don't want it to be a multiple of either of those parts. So I'd multiply it by a power of t. Well, I already have something that looks like that. So I'll multiply it by another power of t. So we'll call that a t squared e to the negative t. So basically all three of my terms are going to look like this, are going to have a e to the negative t term. So now that I have that, let's take a derivative. So that's going to involve the product rule. 2at e to the negative t minus at squared e to the negative t. Okay, do that again. Two a e to the negative t minus 2at e to the negative t. All right. Minus 2at e to the negative t plus at squared e to the negative t. And I think I have some stuff that combines. So equals 2a e to the negative t minus 4at e to the negative t plus at squared e to the negative t. Okay, so now that I have my, this form of my particular solution, we'll go back to the differential equation with it. So y double prime is equal to 2a e to the negative t minus 4at e to the negative t plus at squared e to the negative t plus 2 times y prime. So plus 4at e to the negative t minus 2at squared e to the negative t plus y, which is plus a t squared e to the negative t. All that stuff equals what? Equals 2e to the negative t. All right, so do I get anything that simplifies here? Let me look at my t squared terms. I have at squared e to the negative t, negative 2at squared e to the negative t, and another positive. So I think all three of those annihilate each other. Okay, I have negative 4at e to the negative t plus 4at e to the negative t. Okay, so that kind of shook out conveniently. All this to learn that a equals 1. So what did I learn about my particular solution? Y sub p of t is equal to t squared e to the negative t. All right, so now we have this. I'll write it up here at the top. Y of t is equal to c1 e to the negative t plus c2t e to the negative t plus t squared e to the negative t. And now we need some derivatives let's just plug in 0 first, see what happens. I think we're going to get c1 for free. So y of 0 equals c1 times 1 plus c2 times 0 plus 0. So c1 equals negative 1. So let's go ahead and just drop that in. This becomes negative, that coefficient. All right, so now we can take a derivative because the other piece of information we have is about y prime. So y prime of t equals e to the negative t plus c2 e to the negative t minus c2t e to the negative t plus 2t e to the negative t minus t squared e to the negative t. Let's plug in 0 for everything. E to the 0 is 1 plus c2 times e to the 0, that's c2. The rest of this has t's, just t's multiplied by it, so those are going to go to 0. 1 plus c2 equals 3, which means that c2 equals 2. So here is my final answer for y of t. That is all for the exercises from this section.